So it's not as clear as your old one, but it's decent. I can still see you, which is good.
That's the joke. It should be so much better. I spent
really?
a fortune on it.
What'd you buy? What'd you get?
Shit. Where's the box?
Where's the box?
It's over there somewhere.
Is it Logitech or what?
Dell 4K. What do we call it? Folds you around camera.
Okay. Well, I mean, nothing's gonna beat a DSLR. A DSLR is always gonna be like just like absolute top. Like I'm using a Logitech Brio for this one, and then one sec, I'll show you the other camera. Where'd it go? Oh, there we go. Oh, okay, yeah, it's probably the zoom. Yeah, when you zoom in, yeah, okay, it looks better now. Yeah. It's like zoomies.
It follows you.
Oh, it has that AI stuff where, yeah. That's too funny, man.
Okay, I'll turn that off. It's annoying.
Yeah, no, it's all good. Let me pop the chat out. Okay, cool. All right, now my YouTube's finally working. Ooh, Ace got good questions.
It'll be because it's dark in here.
Yeah, lighting is a big thing, bro. I have like a gazillion lights on my system. I got like 1, 2, 3. I got all these floods on me. I think
I've got quite sensitive eyes. Obviously, well, you can see for yourself.
What you got? Can I see like what your cataracts or something? What am I looking for?
No, I've got very bright eyes, and you've got quite dark eyes. So
I do.
I'm going to be more sensitive to light anyway.
You know what's funny? Because my nonna, my grandfather from Sicily, he has blue eyes, which like blue eyes in southern Italy is like kind of a weird thing, right? Not many people have blue eyes.
Blue eyes are rare anyway.
Yeah, right. But especially
blue eyes
for like
in Italy.
Italians. Yeah, blue eyes in Italy. It's like what? Yeah, so we always joke that's the Normans coming to town or something. Nice. Let's see. What today's Wednesday, day before. Do you guys celebrate Halloween over there? Sensation? Do you guys do Halloween? So yeah, it's Halloween. It's Halloween tomorrow. Tomorrow, I guess, or today-ish, whatever.
Yeah, today at some point.
It's past midnight. When's the last time you've gone out and dressed up, or have you ever gone out and dressed up for Halloween?
When I was a child, like an infant, maybe.
When I was a wee lad.
People stop doing that before they even come to the end of primary school, so before you're 10, you kind of stop.
It's so funny. I feel like a lot of adults do it just because like we try to be like clever and stuff. Like I did it. Do I have any pictures? Oh, I need like Halloween from like last year. Halloween, maybe? Halloween habit. Or just type Halloween into my thing. Oh yes. Yeah, this was me. I went as Gold Darth Vader. Last year.
Gold Vader.
Gold Vader, Darth Gold.
Oh no.
Darth Gold, I like that one.
Yeah, Darth Gold, pretty fun. Yeah. So that was my Halloween costume last year. I don't know. I don't know if I'm gonna go out this year for Halloween.
Wait, what was your mate wearing?
I mean, he had that dude. That's a real samurai sword. Like I was like, bro, this is a real, and he's got like these Yakuza tattoos going on, dog, which are real. It's a very LA outfit. Yeah, he was a tattoo artist.
That's not real. It's cool, but it's not real.
Oh well, I don't think it was like actually made in Japan, but like it's actually sharp. I'm pretty sure. Like it can cut you. You know.
It looks. I'm saying it looks kind of dulled to me.
Yeah, I get what you're saying. Yeah. Like the blade is flat. No, I get you. I thought I remember it being sharp, or maybe it wasn't sharp. I don't know. I'm trying to think other Halloween costumes I had. Let me think. Yeah, in the years before, I just kind of wore gold stuff. I think I was Tweety Bird once.
Tweety Bird.
Yeah, I was Tweety Bird once. Yeah, here we go. This is me as Tweety Bird. This is me and my ex at the time. I was because I was like, "What's a gold outfit?" And she was the cat.
You know, she looks taller than you do.
She was, or yeah, she is. And so yeah, that's actually a funny thing because the first year we dated. So this is always like a thing. Is like to do like a couple's costume or something, right? You'll love this, dude. I went as a koala bear and she went as a tree. Because she's taller than me. This mask is like super realistic, dude. It's like it's great. And I had these slipper feet that I wore the entire time. I wore those. So in West Hollywood, they do a giant parade. And so I walked around with these slippers for like a couple miles in West Hollywood. It was fun. Yeah, so that was a costume I did once. Oh, have you ever seen The Emperor's New Groove?
Possibly.
It's a Disney film. Here, I'll show you. It's
I'm aware of it. You asked me if I've seen it. I don't remember.
Yeah, this one. Yeah, it was I resonated very much with this character. The Emperor guy. He is kind of like me, just eccentric and kind of like whatever. And then there's this evil witch named Isma, I think is her name. But for one of the Halloweens, we went as that group as well. We actually I think we got second place in a costume competition with it. She did a lot more effort for this than me. I just kind of just put on an outfit. I was just like whatever. She went all in on designing a hat and the face makeup. It was pretty cool. But anyways, yeah, Halloween's fun. But I don't think I'll unless I start feeling a lot better. I don't think I'm gonna go out tomorrow night. I'm like one of the kids I teach got me sick. I know it happened. Yeah, I walked he had canceled on me the week before because he was sick, and I was like, "Oh, it's cool, dude. We'll meet next week." And I asked him, "Oh, are you feeling better?" He's like, "Yeah, you know." I'm like, "Okay." Then I walk in, and he's just coughing and everything. I'm like, "Oh, fuck. I'm about to get sick." You are aware
that's
that
one thing most people don't realize.
I am broadcasting publicly, Jeff. Yeah, it's okay. Yeah, what's wrong with me broadcasting publicly? What?
The one thing most people don't realize. Sorry, I keep talking over here.
Go on. Most people don't realize what?
Most people don't realize that most people will get you sick before they realize they're sick themselves.
Correct. Well, this kid knew he was sick. Yeah. Jeff says, it sounds like you're having a private conversation. No, not really. I mean, unless I was mentioning names and addresses, maybe. But wait, do you go to pals' houses to tutor, or do they come to your house? A little bit of both. So, some students are obviously younger. They're in high school. So their parents don't really want their kid going to my house. It's kind of weird. So I go to their house, and of course charge extra for that because I have to travel and stuff. And I'm also putting myself at risk of getting sick. It's not all online. A lot of it is online. And actually, I have to cut this stream short at an hour and a half. I know we went 3.5 hours yesterday, but I got to cut this at an hour and a half because I have a student I have to teach online that has an exam tomorrow, and they can't find any other time. And I'm like, fine, whatever. But that's online. A lot of kids I teach online. Some parents and students, honestly, they really want the in-person because they hate online education. They think it's garbage. I agree, it can be garbage, depending on who's doing it. I tend to think I teach better online because I have more tools, right? I can use colors and things. There's a lot of cool stuff you can do online. But they want the in-person interaction. So some of them I teach still in person, but I charge more, obviously, because it's more of a risk. Anyways, we got a lot of questions today. I gotta end the stream early, so let's start at it. Welcome over to Office Hours. My name is Dr. Gold. This is Actual Education. Streaming helps you with math homework, science homework, all sorts of fun stuff. Let's see. Is Mika in the house? You in the hizzy? You in the house? And then Ace. Ace, are you here? We can do Ace. Ace, yeah, you're here. This is if you're here, Ace. Yes, sir. He says, okay, cool, let's do it. All right, let me find this. Oh my god, this is such a huge image. Y'all sending these full res massive things. Bum bum bum.
1920 by 1080 is fine.
Yeah, I know, but for whatever reason, bro, you want to see here? I'm actually curious because bro, I can see down to the pixels almost. Let's inspect this. I want to inspect this real quick.
9,000 wide. I'll put money on it.
No, 3024. It's 4:3. It's 4032 by 3024. But yeah, that's
4K.
Yeah.
More or less.
No, 4K is Oh, you're right. You're right,
4,000
actually.
wide.
You're right. You're right. Oh, I was trying
No,
to say... No, 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 no,
I'm
no,
full of
no.
shit.
No, 4K
Yeah.
is 2160, right? It's 2160
Yeah,
wide.
yeah.
4K refers to the number of pixels, not
No,
the width. Right?
2160 is 2K.
Oh, you're so right.
1920 by 1080 is HD.
Okay, no. I know what it is now because it's 1440 times 2. No. Wait, what?
1440 times.
No, 1440 is quad HD, right? That's QHD.
Yeah.
2160 is 4K. I'm pretty sure it is.
But it's not tall enough.
Yeah. Yeah. It's 2160 tall, 3840 wide. It's
Okay,
it's double 1920. Is it right? Because 1080 is 1920 by 1080p, right?
Mhm.
So you double the 1920, and that makes it 4K.
So when you said 2160, I just assumed you meant wide.
Oh no, yeah. It is weird that they call that.
Height.
Yeah, it is weird they call that, right? Yeah. Anyways, whatever. Yeah. So stuff's cool like that.
Let's crack on.
What's up, Mika? All right, yeah, Ace. Let me do Ace real quick, Mika, and then I'll do yours. Okay, cool. Here we go. All right, which you need the shaded ones? Okay. Looks like we're doing. Oh wow, look at this. This is tricky. Okay, Ace. I like this. This is a good one. So we have 27 to the x over 9 to the 2x minus 1 is equal 3 to the x plus 4. Do you know how to do this one? Like, do you have any ideas? It's kind of weird. First thing I notice, off the bat, Ace, make them the common base. Yes. So I see like a 27 here, right? I see a 9 and I see a 3. These are all different numbers, but I see that they're multiples of each other, right? So that tells me I can write this 9 as 3 squared, right? Let's just write that as 3 squared. Okay? And that's all still raised to this power. Okay. Now we have 27. 27 is the same thing as 3 to the third. So now we have 3 to the third, all that power. And then this is still 3 to the x plus 4. So the cool thing about this is that we have the same base everywhere, which is nice. Because now I can write this as something new. So if you ever have a to the b all to the c, this is the same thing as a to the b times c. Like the exponent to an exponent, you get to like just multiply them together. So this ends up becoming 3 to the 2 times this whole thing. And here's a key thing. Be careful. It has to multiply by everything. So it has to multiply by this and by this. And then this comes out as well, just times the x. So now you're left with 3 to the 3x. And then this is going to be 4x minus 2. Okay. And even more so, now that I have two things that are the same bases, but they're raised to different exponents, okay, I can combine this into a single thing, right? So if I have a to the b over a to the c, this is the same thing as a to the b minus c. We could use logs, and honestly, yeah, this is an introduction to why logs are cool. I could show that next. I use logs, but I'm gonna write this as a total 3, and then that's going to be to the 3x minus, and again, careful, it's this exponent minus the whole thing. Okay, so you have to subtract it minus 4x minus 2. So this minus is going to hit both things. People always get this wrong. Like, they will only put the minus on this. It hits both. Don't forget that. Don't forget. Okay. So
I would have made that mistake.
It's okay. Yeah, sensation. It happens all the time. Yeah. People see this like, oh, this minus this. Cool. 3x minus 4x minus 2. But then they'll only do this subtraction. They won't realize that the minus sign also needs to hit this. Yeah, it happens a lot. Okay. So doing that, I now get 3. 3x minus 4x is negative x. And then minus 2 is going to be plus 2. And then this is equal to 3 to the x plus 4. Now, where this is cool, right, is that I have something raised to an exponent and that same thing raised to a different exponent. So in order for these things to be equal to each other, Since they have the same base, that means that the exponents need to be the same. So this exponent needs to equal this exponent. Yeah, very good. So you just get negative x plus 2 equals x plus 4. Let's add x. Let's subtract 4. That gets you negative 2 is equal to 2x, which will give us our final answer of x is equal to negative 1. Pretty cool. You could have used this with logarithms. Yeah, logarithms kind of just like explain how this works. If you want to see why, it's actually kind of cool. Here, we could take it from the beginning. Let's take it from this real quick. Actually, you know what? Bleh. I'm trying to think what I want to do with this. Wait, you haven't learned logarithms yet? You're down? Okay, cool. All right. That'll be... So, I mean, there's some basic logarithm rules. Log of a over b is equal to log of a minus log of b. And then the other one you need to know is that log of a to the b is equal to b log a. If we know these rules, we can do almost everything. Okay, so let's look at this, for example, right? So I have 27 to the x over 9 to the 2x minus 1 is equal to 3 to the x plus 4, okay? And this is a key thing. Anytime you see that your variable x is up in the exponent and you're trying to solve for it, you're probably going to use logs. I mean, you can be clever and do this, but sometimes it doesn't work out. And what you want to do is you want to take the log of both sides. Notice I didn't specify what the base of the log is, and I'm not going to because you don't need to. In this question, at least. You can't transfer bond coins, though, Laz. Yeah, sorry. Okay. So, remember, the rule is, right? The log of something divided by something is the log of that first thing minus the log of the second thing. So, what we can do here is, right, we have the log of something divided by the log of something else. So, that's going to be two separate logs that are being subtracted. So, this becomes the log of 27 to the x minus the log of 9 to the 2x minus 1. And this is all equal to the log of 3 to the x plus 4. Yeah, you can buy stuff for others, but you can't transfer coins, yeah. Main reason I had to do that, Jeff, is because, like, too many kids were, like, signing up with alts, and then they would get, like, a certain number of coins doing the easy stuff, and then they would just all pool them together into one account. And I was like, no, stop. Kids will always try to find a way to, like, cheat the system, which is, I can respect it. Like, you should be trying to optimize, for, trying to find a cool solution, but sometimes you just got to do the work. Like, there's not a hack for everything.
Wasn't that why we implemented that other rule, where it was like, well, you have to come into office hours in order to get the backpack?
Yeah, exactly. Yeah. That was the other rule. Yeah. You're right, Sensation. We made the rule that in order to get the item in your backpack, to claim your prize, for me to basically buy you a gift card, you have to come on the stream, because I can tell pretty quickly if it's a duplicate person. Although there are some kids that only use text, and so, like, I'm sure some of them are doing it, but, like, whatever. Can I buy Laz Joma some rolls? No, you can't buy rolls. Rolls are earned, not bought. You know what they told. What I think there's a good quote about this. Like, loyalty can be bought, but it can never be sold. I guess, I don't know. Does it make sense, Sensation? Like, you can buy loyalty, but you can never sell it. Or oh no, you can always sell your loyalty, but you can never truly buy it from somebody else. I guess, yeah. It was it was a Dune quote, actually. One sec. Dune quote, loyalty, bought, sold. Yeah, what was it? Yeah, here we go. Loyalty is a valued commodity. It can be sold, not bought, but sold. Yeah. So, yeah, let's see. Loyalty can be...
Which makes sense.
Yeah, it kind of makes sense, right? Like, you can sell your loyalty to someone, but no one can... You can't buy loyalty from somebody else. It's kind of weird. I don't know. I don't know. It's pretty cool. I like that book. I'm now on the third one. Have you read them, Sensation? Have you read any of the Dunes?
No, the closest I ever got to Dune was I saw the TV series remake in the 2000s.
Oh, okay, yeah. I mean, the remake they just did with Timothy Chalamet is pretty good. But they did part 1 and part 2, which only covered the first book, and now there's Dune Messiah, which I think they're gonna do like a part 3 and part 4 for. And then I'm on the next one I'm on. It's called like Children of Dune. Yeah. Oh, to me it's my way of going to bed. Like if I need to like go to sleep, I just start reading Dune, and after about like 5 or 10 pages, I black out. I'm just like, cool, sleepy time. Okay. Right. Okay. We got logs, minusing, all sorts of weird stuff. This is where we're gonna use our other rule, which says that if you have the log of something to a power, you can pull this power out in the front. Okay? So, doing so, I can pull this out in the front. And so this is going to be x log of 27 minus 2x minus 1 log of 9 equals x plus 4 log of 3. And then the next trick we're going to do, which is very similar to what we did in the other problem, is we're going to rewrite these things as 3 to exponents. So I can write this 27 as 3 to the third. I can write this 9 as 3 squared. And now we have our exponent rule again, where I can pull the exponent out front. So this thing's going to come out front, become 3x. This thing is going to come out front, become 2. And now I have something log 3, something log 3, something log 3. So now all the log 3s can go away. Very cool. So now you're left with 3x minus 2x minus 1 is equal to x plus 4. This is going to be the same thing as what we saw up here, because then this becomes 3x minus 4x, so that's negative x, and then it's going to be plus 2 equals, well, did we do that right? Yeah, plus 2 equals x plus 4 minus 2. Put that over there. That becomes 2 minus x. This becomes minus 2x. And then, yeah, you get the same thing. X is equal to negative 1. Isn't this method longer than the other? It is, but it's good to know because these rules will eventually come into handy when it's not as easy to see powers of things. You might have like really high numbers that you're just like, I don't know that that's like 6 to the 4th or something. But yeah, we'll get into it. Anyways, let me make sure I do everyone else's questions, Ace, and then I can do 26 for you as well if we got time. Is that cool? Do you recommend taking advanced functions? No, I would skip straight to calculus. You're smart, Ace. Like, yeah, just skip the calculus. I can teach you any of the advanced functions you need. Or you can teach yourself. It's not that hard. Yeah, I think you're pretty smart, Ace. I think you could take calculus. The reason why... So advanced functions is basically pre-calc for you guys in Canada. And yes, pre-calc is useful, but I find like 90% of the time, you just end up relearning the pre-calc stuff you need as you go along in calculus. So in a perfect world where you took pre-calc and you remembered everything in pre-calc, that would be awesome because then you don't need to relearn it when you take calculus. But more often than not, you're going to forget like sine, cosine stuff. So you might as well just like learn it on the fly, I feel like. People say advanced functions is easier than calculus or easier than functions. Yeah, I mean, what are you having? It looks yum. I had some, it was chili. I made some chili. No bratwurst today. Anyways, okay, cool. Good question. Let me help some other people out, Ace. And then I'll see if I got time for number 26. But good job. Okay, let's help out. Yeah, you're very welcome. Yeah. Okie dokes. All right, Mika, you wanna come up the stage and get some help? Let me know, Mika.
Hello?
All right, what's cracking, Mika?
Hi.
So looks like we got interest, like compound interest and stuff. Is that what's going on here?
Yeah, it was part of my logarithm textbook homework.
This is cool. This is investments, something I should have, but I don't.
Oh no.
Oh no.
Anyways, okay, yeah, we'll do Ace. You're good. Okay. So they say investment earns 7% interest compounded annually. The amount A that the investment is worth is a function of time is equal to this. This is cool. So this comes from A is equal to P, and then it's 1 plus R to the T. I've gone over where this equation comes from. If you want to know it, it's not that like crazy. It's just like every year. Let's say for instance something was gaining by 50%. Okay, and let's say you had like $5. Let's say to start. Okay, how much would you have in the second year, or let's say after 1 year?
It gains 50%.
Yeah.
$10.
Well, close. So 50% means half of this is what it
Oh,
gains.
2.5.
So it gains 2.5, right? So do you see how that gets you to 7.5? Okay. And what did we do? What did we multiply 5 by in order to get to 7.5?
1/2.
1.5. So 1 plus 1 over 2. Yeah. So 1 over 2 is what we got to get the gain, right? If we multiply this by a half, I got the 2.5, but then I had to add it to the original thing. So that's the same thing as multiplying it by 1.5. This would get us to 7.5. Yeah. So I can also show you here. We'll show you. So what happened was, right, you multiplied this by a half, right? That got you 2.5, and then you added it to the original thing. Okay? So doing this is the same thing as 1/2 times the 5 plus 1 times the 5. Right? I did a 1/2 times the 5 to get that, and then I added it to 1 times the 5. Do you see how I have the same number here? 1/2 times 5 and then plus 1 times 5?
Yeah.
You can pull out the 5 from both of these, right? So if you pull out the 5, that gets you 5, and then you're left with 1/2 plus 1. And so then this just becomes 1.5.
Oh, okay.
They kind of make, yeah, I know it's a little tricky. And also, like, I didn't choose the nicest numbers, like 5.5. Like, this kind of sucks, honestly. Let me think. Let me do like a slightly better number. Let's say something gains by 10%. Maybe that. Yeah, let's do 10%. I think 10% is cool. Let's say something has like a 10% gain. So if I start with $5, right, and I'm gonna get 10% of that back, right? Do you know how I figure out what 10% of 5 is?
5 times 0.1.
Good. Exactly. What's up, Bella? Yeah. So I'm gonna do this. So I'm gonna do 5 times 0.1, and then I'm gonna add it to the original 5. So that's the same thing, right, as multiplying this whole number by 1.1. That's the same thing as 1.1 times 5. Okay? Which, for the first year, right, if I'm adding 10%, that's just going to give me $5.50, right? Because 10% of $5 is 50 cents. Okay, so this gives me $5.50. All right, now let's say it gains another 10% into the second year. All right, what am I going to do? You can think about it step by step. So you have your initial $5.50, and you know it gains 10%. So we can figure out how much it gains by doing what?
Multiplying it by 1.1.
Good. Yeah. So if you want, so yeah, here's the cool thing. if you wanted to know the gain, right, I would just multiply this by 0.1. That's how much it gains, which in this case would be it's gaining 55 cents. But if I want to know how much it's equal to, right, it's going to be multiplying that by that 0.1 plus the 550 that was originally there. So it's like taking this number and again multiplying it by 1.1, which ends up giving you that's $6.05. Okay.
Mm.
So what this ended up being was now this was okay. This number, which is this, so 1.1 times 5, all times 1.1 again. And you should start to see a pattern here. Do you see how after 2 years, it's 1.1 times 1.1 times 5?
Oh, so that becomes the exponent.
Yes. So this becomes 1.1 squared. So after 2 years, it's 1.1 squared. So you can kind of make the guess, right? That after 3 years, it's going to be 1.1 to the what?
3.
Good. Yeah. So that's where this equation comes from. Okay. So you see the 1,
Oh.
right? And then this is the rate, which in this case, right, when we did 10%, that was the 0.1. That's where we got the 1.1. This right here is the initial amount you start with. That's the P. And then this exponent is how many times it just keeps compounding. So after how much time it's hit. Yeah. So hopefully that makes a little bit more sense. That's where it comes from. I know. They give you these equations and you're just like what? Where the hell did this come from? Like, I don't know. Okay. So let's get back to like what the actual question was. So it says, use the investment question to determine the value of the investment initially when t equals 0. So to do this, Mika, what do we do?
Use the equation and then make the exponent 0.
Yeah, good. Exactly. You just set t equal to 0. So this is 500, 1.07, and then we're going to raise that right to the 0 power. What happens when I raise something to the 0 power?
It becomes 1.
Yes. Yes. Some people think this becomes like 0. That's not right. Anything to the 0 power is 1, except I think 0 to the 0. I think 0 to the 0 is kind of like, we don't know what that is.
Undefined.
It is indeterminate? Yeah. Okay, cool. Thanks. Yeah. Right. So this goes away, and you're just left with this. Do you see how this, right, it was the initial amount? Remember, it was P, 1 plus R to the T? So once this all goes away, you're left with P, which is called the principal, by the way. Principal means like the initial amount you have. Okay, cool. So yeah, this is just 500. All right. What about after 2 years? What are we going to do for that?
Make t2.
Good. Now, for this, yeah, they used kind of ugly numbers. Because I don't know what, like, 7% of 7% of 500 is. I mean, that kind of sucks, honestly. So, yeah, you do have to use a calculator. What do you got for a sensation? Show us. I'm pulling the calculator.
Look at this over-engineered piece of shit.
What is it, dude? What is it?
I've been trying to take this apart for like a day.
Oh, it's an external hard drive?
Look at the amount of
Yeah, they really
things.
They don't want you to take the tabs off. Yeah. Do you know why they do that? But you know what you're doing? There's a name for that. What does it start? What is it? What's the name for that? It has to do with seafood.
Seafood?
Yeah. Shucking.
Calamari.
You are shucking. You are shucking. You're
Oh,
shucking.
Yeah.
You're shucking a drive. So there's this interesting. It's a little side tangent. There's this interesting phenomena where buying external hard drives was sometimes cheaper than buying the drive without the enclosure. Like it was cheaper to buy externals just because of market factors. This is a good economics thing, Bella. Just because of like how things were selling, it was more expensive. It was cheaper to buy the hard drive with the enclosure around it than to just buy the raw hard drive. So people would buy these externals and then they would shuck them by like, again, like you shuck like clams. You'd pull the raw drive out and you'd get the same drive for a cheaper price. Yeah, exactly like that. Yeah. And so they intentionally made it difficult because they didn't want people shucking all these drives. There you go. He did it. 76 on my econ test, but that's without the FRQ. Okay, so does that mean your grade's going to go up, Bella? Hopefully. Oh, so you said I got 86. Nice. Good job, Bella. Yeah, 86. That's solid. Nice.
Nice.
Okay. All right, back to this question. Let's pull up the calculator. So you just put this in the calculator. Do you know how to use a calculator, Mika? I know some students like don't. They're just like, I don't know how to use this thing. Okay, good. Like I have one student in my Discord. What's his name? His name is Cuber. I love Cuber. He's been with us for a while, but he like bombed his last test because he didn't know how to use the calculator. He's like, I didn't know how to use it for the exponents. I'm like, bro, dude, like, can I teach you, please, dude? Come on. Okay, and then this is easy. We just do this for when it's to the fourth. I assume the next part is where you need help, right?
Yeah.
Okay, good. Yeah, that's kind of tricky. All right, so this is 0.40. Okay, cool. So now it says, how long will it take for the investment to double in value? Okay, this is a little trickier. Okay, so we're gonna use our same equation here, right? So A is equal to 500, and then Jeff does have a shortcut. There's a shortcut Jeff's talking about. So remember, A is the amount. So if I want this investment to double, what is A going to be equal to?
2.
Close. So remember that it starts at 500. So what's double of 500?
1,000.
It's 1,000. Good. You're going to put 1,000 here, Mika. Because this is double what this is. Okay? So this right? This is always the start. And this is the finish. And if you want the finish to be twice the start, you just need to multiply the start by 2. If you were to put 2 here, I don't think you would get an answer that makes sense. I don't think actually an answer is possible for that to happen. Maybe if you had negative time, Jeff, could you do that? Yeah, maybe with negative time you could do it. But yeah. So yeah, that's what this is going to be. I assume Mika can use logs. We'll have to see. Do you know about logarithms, Mika?
Oh yeah, I'm learning that now.
Okay, we're going to show you why. And this is cool. This is why I showed logs to Ace earlier. So I'm going to move this over. So I'm going to divide both sides by 500. Now you're going to get 2. So now you get 2 is equal to 1.07 to the t. Okay?
Mm-hmm.
And this is where logs come into play. Because anytime you see the variable you're looking for is in the exponent, you want to use logarithms to pull it down.
Mm-hmm.
So if we take the log of both sides, then this exponent, right, from, where was it? This rule I talked about right here, right? Log of something to an exponent, the exponent comes down up front.
Mm-hmm.
This exponent's going to come out right over here. Well, it's going to like, here, let's move everything over. Get out of the way, log. Okay, okay, cool. So this is going to come here. Okay. Now, you can divide both sides by the log of 1.07. Divide by the log of 1.07. And then this is our answer. T is equal to log of 2 over the log of 1.07, which you can do in your calculator, right? I can just say log of 2 divided by log of 1.07. And then we're going to hit enter here. And that gets me 10.24. Okay, so 10.24 years. Notice how I didn't have to say what the base was, and actually you could use ln, which is natural log, and you'd get the same answer. If you do this, you get the same answer. As long as you're using the same type of log on the top and the bottom, it'll work.
Okay.
Okay? So if you wanted to know how much it triples in value, right? You see how this 2 here kind of represented the double?
Mm-hmm.
So for triple, you just change this to 3.
Okay.
The real way would be to change this to 1,500 and then divide by 500, but then you'd get 3 again. So if you want to be, quick, all you do is you take your original thing you had here, and then you just say log of 3 over 1.07. And that gets you 16.24 years. Yeah. Does that make sense?
Okay. Yeah.
Yeah? Cool.
I was confused by the wording.
Yeah, the wording is
From
weird,
the
and I
paper.
understand why you wanted to put 2 here for double, but yeah, it's double what it initially was, so it goes from 500 up to 1,000. That's the tricky part.
Yeah.
Yeah.
Okay.
Nice. Good job there, Mika. Yeah.
Thank you.
You're very welcome.
Honestly.
Right.
Well done.
Yeah, so Jeff, Jeff brings up a good point here, which there is something called the rule of 72. It's a useful thing, which says that the doubling time is roughly 72 divided by the interest rate. So the amount of time it takes for something to double is 72. So in this case, Mika's question was 7%. So if you do 72 over 7, you get 10.29, which we can see, it was pretty close. Like 10.24, we were super close. This is very, very close. So yeah, if you ever want to know like how long is it going to take for your investment to double, just take 72 and divide it by the percentage. And it's just a whole number. You don't use it as a decimal. Can you derive the formula? Probably. What? A equals P 1 plus R over T. So A over P. So the initial. So the amount you have divided by the amount you started with. This has to be equal to 2. Okay. So then, let's see. How does this work? Because you want to solve for t. Let's take the ln of both sides. Pull that out front. And then I have this, right? So I have ln of 2 divided by the ln, or minus the ln. No. Well, no, it's divided by, right? Yeah. Divided by ln of 1 plus r is equal to t. Okay. I know this is like something with 72, but let's see. Okay. Oh, here's another cool thing. So ln of 1 plus r. Oh, interesting. Wait, how do you pull that out? How do you derive this formula? Is there some weird thing here? Can ln of 1 plus r be expanded with like a Taylor expansion, Jeff? Is that where that comes from? Maybe. Let's check it out. It probably is. Let's see. Taylor expansion for ln of 1 plus x. That's 1 plus x squared. Okay, 1 plus x is x minus x squared over 2. Okay, I think this is the one I want. I want this. And also, I think this only works for low percentages, right? Maybe? Because we're assuming x is small here. Okay, so it's approximately equal to... This is kind of cool. So this is the same thing as ln of 2 over r minus r squared over 2 plus r cubed over 3. Ooh, okay. And then... let's remember that we're going to give r as a percentage. So it's really the value we give divided by 100, right? So r is equal to the value I give over 100, right? It's actually 100 minus... Oh, okay. Yeah. I'm just kind of curious if it works like this. All right, so ln of 2 over x over 100 minus x squared over 2 times 100 squared plus x to the third over 3 times 100 cubed. 100 cubed? So I think like we start just like nixing these terms off. If you're going to do that, expand in terms of 1 over x, not terms of 1, not in terms, what? What is ln of 2? Oh, in terms of x. Yeah, 1 sec. Let me see what ln of 2 is. Oh, also, I did ln, not log. No, ln's okay. Sorry. So it's 0.69. ln of 2 is apparently 0.69. Because I'm using the Taylor expansion for ln. Yeah, okay. I just want to see if this works. So I think I already kind of have it here, right? Because look at this already. So I have 0.69 over x over 100. So then that gives me, yeah, this gives me 69 over x is equal to t, which is close. Yeah, I think it's decent. Yeah. Okay, cool. That's actually kind of cool. Very cool, Jeff. I like that. All right, let me help out Bella. What's up, Bella? Which one do you need help with, Bella? You did some? Okay. That's cool. Are we doing more economics or is this physics? It's in the third picture. Okay. I like physics. Is it this one? The questions I need to do are on the top. Okay. 1 through 8. Oh, and these are the ones you've done so far. Okay, cool. $72 works for interest rates near 7.2%. That's too funny. I don't know if I did it right. Okay, cool. That's all right. Here, we'll just check them for you. That's good. That's all right. That's all right. And then questions 1 through 8. Oh, I see. Q's are different than P's. Uh-huh. Okay, cool. All right. Let's look. It's funny that your book says questions and then problems, but like says they're 2 different things. Like, excuse me? Like what? How is a question different than a problem? I guess you got to do more work on a problem, and a question is more of like a yes or no answer. Is that what they're getting at? Kind of interesting. Okay. That's coming in, and then let me... Okay, cool. Here we go. Okay. Let's look at the first one you did. And then here, I will put this on another page, so we'll just flip back and forth. Okay. So it says, 1 car travels due east at 40, and the second car travels north at 40. Are their velocities equal? Can you explain? Uh-huh. So you said yes. So technically, Bella, their speeds are the same because they're both traveling at 40, but velocity contains a direction as well. So velocity is speed plus direction. So you would technically say no, and you would say different directions. Same speed. Okay? Same sped. Sorry, speed. You can't say sped anymore, apparently. That's like a bad word or something. I don't know.
Are we talking about more internet censorship?
Yeah, internet censorship. Yeah, I know. You know what's funny? I was helping a professor today, and he was telling me that like he feels like he's being castrated in his university because there's increasingly more and more rules about what he can't do, and he's like, I'm just trying to teach, like they're coming up with all these like, well, if the kid feels too stressed, then you have to give them the option to go to a quiet room to take the test or something. And he's just like what? Like, what are all these rules now? Like, I'm all for like accommodating for people with disabilities. And he said that it's been a big change in the last 10 years. He said earlier, like it used to be 1 or 2 kids needed this like special accommodation. Totally cool. Now he's like half the class like requests it because it's an obvious advantage, right? To have more time on a test and to also be put into a special quiet room where you can probably cheat easier, honestly, because the teacher's not watching. Yeah.
See, it's interesting. That was forced upon me.
Oh, they
during
They
my
said
last
like
test.
they're like you're fucking special. Like you need to go in the special room.
You should go sit in a room on your own. I was like, well, I don't want to. It's like, well, you should because it's there for you. But yeah, there was
Yeah.
me and a teacher, so the teacher was fully fucking watching me.
Yeah. Nowadays, yeah, I think kids just take advantage of it, or they're soft. I don't know. Whatever. Okay.
Oh no, this was last. No, this was this year.
Oh. Oh, interesting. Well, I mean, also like probably different countries as well. Can you give several examples of an object's motion in which a great distance is traveled, the displacement is 0? Ooh, I like that. Bouncing on a trampoline? Yeah, that's cool. Yeah, because you go all the way up, you come all the way down. You traveled a lot of distance, but 0 displacement, because displacement's where you start and where you end. Can the displacement vector for a particle moving in 2 dimensions ever be longer than the length of the path traveled by the particle over the same interval? Can it ever be less? Okay, so let's remember displacement, right, is start to finish, where distance is the length that you travel, okay? So displacement can never be... no, education doesn't have ads. Yeah, Twitch does, unfortunately. If you want to go watch ad-free, I'm pretty sure YouTube doesn't put ads on my stuff yet. Yes, exactly. We're going to get to the triangle inequality.
Oh, you could stop being mean. It's like a $5. Go fucking...
Go pay $5. Yeah, there you go. It's a $5. This is corrupted static data. Okay. Anyways. Yeah, so Jeff talks about the triangle inequality, which I don't know if you've heard about that, Bella. Have you heard about the triangle inequality? It's pretty cool. Okay, so it says anytime you have 3 sides on a triangle. Let's say we have like, I don't know, side A, side this, and then side this, okay? The sum of any 2 sides, so adding any 2 sides has to be greater than the 3rd side. Okay? So, yeah, right? Yeah, okay, yeah. So this side plus this side has to be greater than this side. The reason why he brings this up is that a triangle, right, represents like 2 legs of a path, right? This is a path, this is a path. And then this represents the displacement, right? If this was the start and this was the finish, right? This is like the distance is like this whole thing. So yeah, so what that tells you is that the displacement, right, which would be the 3rd side of any triangle, can never be bigger than the sum of any other 2 sides. So that tells you right away, like, displacement can never be bigger than path distance. Okay? But certainly, right, path distance can be longer than displacement. And you can talk about the Pythagorean theorem, for instance, for that. I mean, if you really want to, like, you know, get at it, just name drop and just be like triangle inequality. And be like, yo, bro, figure it out. But, yeah, the way to word that is that the displacement will always be shorter or equal to the distance. Because, I mean, the alternative, right, is that you could just do this. You could just do a straight line. And in that case, the path distance is the same as the displacement. But displacement will never be bigger. So I'd say displacement is always less than or equal to the path. Distance on the path or whatever. Yeah. Cool. That's a good question. I like the thanks, Jeff, for like the triangle inequality was good. Paths matter in this point. They do. Is JavaScript called math.hypot? What? Nintendo, what the fuck? What are you saying, dog? Excuse me.
Are you insane?
Do you know where your kids are? It's 10 p.m.
Listen very carefully, right? You type with your fingers, not your fucking palms, right?
Your palms. I'm mashing my keyboard. Wait, do you know this meme? I wanted to put this meme in one of my TikToks, but then I was afraid it was gonna get like demonetized or something. What is it? Typing keyboard.
With your face.
Yeah. Mash. It's an old meme. but it checks out. This one. Anyone seen this one? This is such an old school meme.
Oh wait, no, I do remember this.
Yeah, you remember? But I was like, I'd probably get into trouble if I don't know. The internet has changed these days, but yeah. So that
they can't take the even the simple gore anymore.
Yeah, I can't take that. Yeah, even the cartoon gore is not okay. Okay. All right. But it's good. You have humor about how you were learning. Yeah, you gotta have humor, dude. If you can't laugh at it, you're too serious, man. Okay, during baseball practice, a batter hits a very high fly ball and then runs in a straight line and catches it. Which had the greater displacement, the batter or the ball? Well, obviously the batter, right? Because, I mean, the batter, right? Oh, wait. Which one had the greater displacement? Oh, sorry. They're the same. Sorry, I thought we were reading distance. Yeah, they're the same. No, they're the same. Because the start and the finish of the batter and the ball is the same. Yeah, you're right. Yeah, good job. Okay, sorry. I was reading the distance. If v equals v plus v1, v is necessarily greater than v1 and or v2. Greater than? What do you mean by greater than? Like the magnitude? Yeah. Yeah, exactly. Yeah, Jeff, do you think we're talking when they say a vector? Oh, this is the magnitude. Okay, sorry. So do you see how they put arrows up here? Up here means we're talking about vectors. Without vectors, without arrows, we're talking about the magnitude. Yeah, they're talking about magnitude. Okay, cool. Thanks, guys. Okay, so is the magnitude of V greater than V1 and or V2? No. I don't think so. Okay, yeah. Yeah, so this is a good one. So let's say, for instance, that V1 was like 5 to the right, and then V2 was like 5 to the left, which was negative, which are technically the magnitudes of these are both 5. Then adding these up, right, the directions cancel. And so you just get that V is equal to 0. Do you think women are more concerned with magnitude or direction?
Oh, no.
I think they're more concerned with the bank account, at least at my age. I don't think they really care about magnitude, unless we're talking about height. Like height does seem to make a big difference. What's up, Phobos? Thanks for the raid, dude. Big shout out to Phobos. Phobos, you're streaming these days, dog? Sorry, my bad if I forgot you were streaming. Let me see your stream. I better be following you. Am I following you? Oh, I am following you, Phobos. Nice. Okay, cool. Are you on our calendar yet, Phobos? Did Penn Center add you to the calendar? So we have if you go to... What's up, Phobos? What's up? What was going on your stream? Are you doing some math help? We're doing some physics help right now. Phobos is a lady concerned with awesome. Okay, yeah. We should get you on the calendar if you're streaming and whatnot, like regularly. For those that don't know, in the Twitch here, here's a calendar we have of all the awesome math streamer friends of ours. And when they're streaming. I guess I'm the only person here on Wednesday besides you, Phobos. Phobos was streaming. So it's kind of a helpful way for people who are trying to learn more or get help with their classes. They can find out which one of us is streaming. Asymptotic analysis and comp sci stuff. Nice. Yeah, comp sci is great. I was helping someone with comp sci earlier. What language was it in? Was it in Python? C++? JavaScript?
Filthy Python.
Filthy Python.
Python is for children.
No, dude, what's that called? Scratch? What's that one language?
Well, Scratch is for children.
Scratch is literally for children. Oh, Rust. Oh, they're coding in Rust. They're coding in Rust Sensation. Coding in Rust. I don't know. I don't even know what Rust is, so I have no comment on it. But wait, is Rust the graphical one? Is that the graphical coding?
Isn't Rust like Golang or something? I can't remember now.
Yeah.
it's again, children use it, so I don't.
Yeah, Sensation's a C++ enjoyer, dude. Yeah,
No,
he's like
I'm assembly.
assembly. Wow, he's even more hardcore, dude. He's super hardcore.
That's dope.
ASM, dude. Wow, dude. Okay, let's see. 5. What was the question for 5? Is it necessarily greater? Yeah. So the answer there is false, and then it depends on the amounts and the symbols. Yeah. For this, I would say direction. I would say direction. Probably a better way to do it. Okay. Cool. Question 6. Two vectors have the same length. Oh, sorry, have the length, 3.5 and 4. What are the maximum and minimum magnitudes of their vector sum? Oh, that's cool. So I think you probably wrote this right. Yeah. Ooh, is that the hard drive we got here? What do we got? Oh, dude, it's not even SATA, dude. That's IDE? Bro.
Yeah.
Bro, that's old, dude.
I don't even think I've got the ability to open this.
Yeah, I think I have some. No, I have an adapter. I have a IDE hardener. You need like one of those like enclosure things. They sell them.
2007.
Yeah, that's old. It's older than some of the kids in the server. Good. So you said, let's see here. Is this 3.5 you put down? Okay. So yeah. Okay, so let's go over this. So they're saying you have two lengths, right? 3.5 and 4. What's the maximum and minimum of their sum? So let's think about this. So if this is 3.5, right? And then you have another vector that's 4.5, right? The way to get the biggest vector out of these would be to add them together, right? If we add these together, then I get a super vector. Yeah, right? You see that? Yeah. So that would be equal to 8. Yeah, sorry, I can't add today. If you wanted the least to happen, right? Yes, exactly. Yep. You subtract them, right? You could change the direction such that this one was pointing in the opposite direction. And then that would give you 3.5 minus 4.5, which would be -1. So the minimum is just 1. Jeff, why are you saying 4? What are you saying 4 for? What's the 4 coming from? I think the max is equal to 8, and min's equal to 1. Oh, my bad. Oh, did I screw up? Oh, I did screw up. Sorry, I said 4.5. Sorry. Oh, man. Sorry, this is 4. Maximum is 7.5 then. I wrote down the wrong thing. And then the minimum is 0.5. Yeah, I just added them together. That's when the max happens. And then you subtract them to get the min. Yeah. Okay, cool. Let's see. 7. Can two vectors of unequal magnitudes add up to give a 0 vector? No. Right? I don't think so. Yeah, so yeah. Yeah, 1 is definitely no. Yeah, you can't get a 0 vector with unequal magnitudes. Just think about that. If you have this, to get a 0 vector, you need something to be the same length and pointing in the opposite direction. Can 3? Can 3 unequal? Well, yeah, right. You could go back and forth, and then you could go nowhere. Or you could do this. Yeah. Jeff has this right. You could go up this way. You could go down a little bit this way, and then you could come all the way back. Right? And then that would also give you a 0 vector. Any triangle demonstrates that. Yeah, Jeff's exactly right. Any triangle does that. Yeah. So if you want to say this, you can say yes. Yeah. Oh, and you know what? This I like this. This is also valid. You did it in 1 dimension. That works as well. But this would need to be 7 minus 5 minus 2. Yeah. You want this to add up to this. You want them all add up to 0. Can the magnitude of a vector be equal to one of its components or less than one of its components? Yes. It can definitely be equal to one of its components. Yes, right? If it had a straight line, well, look, the x component is equal to the magnitude of it. And it could definitely be less, right? Or can it be less? Yeah. Well, can this be less than this? No, actually, I don't think so. Right, Jeff? Right, the hypotenuse can never be less than the opposite of the adjacent. I don't think so. Yeah, it can be more. Good, yeah, square root of x squared plus y squared is always greater than the square root of x squared. Correct. Yeah. So yeah, so this is what they're, so the first part is yes, the second part is no. Because let's remember, this would be equal to the square root of x squared plus y squared. And then the components, Bella, would be here. Be this and this. So this would be x, this would be y. Yeah, you see that? Right, this always has to be bigger than this, right? Square root of x squared plus y squared. I mean, only if y is equal to 0 can they finally equal each other. But yeah, okay, cool. Nice. So yeah, yes, but no. All right, let's see. I got like, yeah, I got 10, 20 minutes. Let's see if we can run. Do we have any other questions from people today? Ooh, we do. Lost in Saga's calculus question. Here. One sec, Bella. Let me help out Lost in Saga with their calculus question, because we went through all 8 of these. When is this due? Is this all due tomorrow, Belle? Oh, it is? Okay, cool. This is probably correct, what you're doing. I can kind of see it. Let me see real quick the ones you needed help with, right? What was it? 10? 10? Like just 10? Just wait, let me just see real quick. Wait, that's problems. Questions? Wait, one sec. Did we go through the wrong ones? Oh, I don't see a page with 7 and... I don't see 10 on there. I see 7. Right? On the screenshots you sent. And then I don't see 9. Yeah, so maybe, yeah, here. Find me the... Yeah, send them over. Okay, and here, let me do Critical's question real quick. If I have time, I have another student in 20 minutes that I have to teach, like, for money. So, but I might have time. Let me do Critical's question real quick. Okay. 17 and 19. Oh, double integrals. Oh, ooh, I'm about to get wrecked. Uh-oh.
I didn't do fucking shit.
All right, here we go. 17. Okay. I gotta remember how this works. Okay, so by symmetry, I'm just gonna figure out what one of these are. And then I'm gonna multiply it by 2. Is that okay? Yeah, r d theta. Yep. But it's like, which one's the outside, which one's the inside, right? That's the issue. Well, yeah, I can assume these are symmetric. Okay, so we need to go from here. Or wait, really? From here. How does this work? Oh, you're okay. Put it on the charger. Yeah, no. There's a way to do this RD theta. I just have to remember how this works for integrals.
Listen, if it's running off batteries, you're doing it wrong.
Is it RD theta? RD theta is arc length.
No idea.
One sec. No, okay, you're right, because that works for a circle, right? Integral from 0 to 2 pi of r dr d theta. That gets you pi r squared. The old hardy hard joke. Yeah, okay, alright. Okay. Okay, I think I just have to figure out, and wait, use a double integral. Right. Because r is changing. And so is d theta. Okay. I believe this is 0. This is then equal to pi. And then you come all the way around, and then this is 2 pi. So I think we're going to go from... Uh-huh. Okay. I think we're going to add the integral from... So you're going to go from pi... Sorry, you're going to go from pi over 2. Let's do it for the blue one first. Sorry. So you have pi over 2, which represents this point over here, down to pi of r, which is 1 plus cosine theta. And then you're going to say dr d theta, but then you have to do the integral in the right direction. So I think I want to do this. I think I want to do theta first. Oh, okay. Uh-huh. Okay. I think this is it. And then dr, how does this work? Oh, I'm blanking. My sick brain, dude. 1 sec. If I see an example of it, I'll remember it. It's just I haven't done polar integrals in so long. Polar integrals, my good friend. You really just need a quarter of it from 0 to 2 pi and then multiply by 4? Yeah, I agree. But I want to show them like how to do it methodically. Yeah, but I don't think it's a double integral though. Mm-hmm. Integral from 0 to r for each theta, and then theta from 0 to pi over 2? Ugh. Yeah, it's weird with the over. Like, this one, I'm not, like, too bugged out about. It's just when we have, like, the overlap. Okay. I think you have to find where they intersect first, right? So I have to set the r's equal to each other. So I say 1 minus cosine theta is equal to 1 plus cosine theta to get, like, the boundary points here, which you can see visually what it is. But if we do that, I get that. Okay, I move that over. I subtract that over. I get 0 is equal to 2 cosine theta. Okay. Cosine theta is equal to 0. So my boundary points are theta equals pi over 2 and 3 pi over 2, which I can see, right? This would be pi over 2. This would be 3 pi over 2. And then integral r dr d theta. Cool. So yeah, this goes from 0 to r. Or actually, no, sorry. This goes from... Do we say pi over 2 to 3 pi over 2? And then this r goes from the inner one to the outer one. Which is weird, because this is the outer one for the first bit of the angle. Or actually, we're going from pi over 2. So this is the outer one. But it's 0 for this one? How does this work? Like, because the thetas are different. Like, there are different thetas where this is happening. It is 2 times the area on the top. Yeah, I know how to do it, like, by cheating and stuff, but, like, I want to use this double integral. I know, like, realistically, I can just figure out this area multiplied by 4. By symmetry. But I want to know that there's, like, a methodical way to do it. Okay. I mean, let's just see, actually, if that works. Because you have the answer. Do you know what the correct answer is? So, let's do r. And this is 0 to r. Okay, 1 plus cosine theta. I'm going to say r dr d theta. And then this integral is going to be from pi over 2 to pi. So I'm just going to get... when I'm doing that, I'm literally just getting this. Okay, so then that's integral 3 pi over 4 minus 4. That's the answer? Okay, we'll see. And then this is... the integral of r dr is r squared over 2. So you have 1/2 r squared evaluated from 0 to 1 plus cosine theta. Okay. D theta. So you're just going to plug that in, right? So then I have... what is this? 1/2 1 plus cosine of theta squared d theta from pi over 2 to pi, which is going to be 1/2 times 1 plus 2 cosine theta plus cosine squared theta d theta. Oh, this sucks, man. I got cosine squared in there already, dude. No. I want to integrate that. That sucks. Okay, whatever. So we get 1/2 theta from pi over 2 to pi, plus 2 sine theta from pi over 2. 1 plus cosine theta squared. Yeah, that's what I had here. Yeah, and then I expanded it out. I'm pretty sure I expanded it out, right? And then the integral of cosine squared theta. I don't want to do that. Integral of cosine squared is u is 1 plus cosine theta. Oh, okay. Yeah, but then I need another sine theta in there. So it's x over 2 plus sine 2x over 4. And then this is from pi over 2 to pi. So let's evaluate some terms here. 1/2 of pi, so this is just pi over 4. Sine of pi is 0. So then we get minus 2, because sine of pi over 2 is 1. And then this is going to become plus pi, it's the same thing, pi over 4. And then 2 pi and pi, both these terms go to 0. Okay, so I get pi over 2 minus 2, and then I think that's all times 4. So that's a different answer than you got. You got 3 pi over 4 minus 4. I'm going to get 2 pi minus 8, which is weird. That's negative. That's negative. That's negative. Ew. Let me see. Where there's a will, there's a way. I shall find a solution. Yeah, my answer is 3 pi over 8. Yeah, it's apparently not right. What do we do wrong? Oh, I'm seeing. So someone did something pretty similar to what we did. That's what they got. They did the same thing. They did 0 to pi over 2 of the 1 minus. Okay. Okay, so they took this one. For the quadrant. Wait, for the whole quadrant? Yeah, no. So they went from here. They went from here to here. They went from 0. So okay, they also didn't do this. They did this with a geometry hack. Yeah, 0 to pi over 2. I did the blue one. I did the blue one from pi over 2 to pi, which I thought should work, right? Should get the same answer. No, did I do something wrong? Oh, I did do something wrong. Sorry. I forgot to distribute the 1/2. Yeah, okay, sorry. There's a 1/2 here. This is 1. This is 1. And then there's another 1/2 coming into this. So this makes it pi over 8. Oh, I messed up. Messed up so bad. Okay. So, okay. So pi over 4 plus pi over 8 is 3 pi over 8, right? minus 1 times 4. 12 over 8 is 4 over 3 pi minus 4. No, it's 3 over 2. Sorry, I'm so dumb, dude. Sorry. Oh, dude, my brain today, dude. I'm so mad at being sick. I hate it. Okay. 3 pi over 2 minus 4. Yeah, okay, cool. Yeah. And is that what he got? They got 3 pi over 4 minus 4. Ugh. Okay, something's like slightly off. No, but they also got 3 pi over 2 over 4. Are you sure that's the right answer, Critical? Yeah, I got 3 pi over 2 over 4. I think this is what it should be. I don't think it's 3 pi over 4 over 4. Oh, 3 pi over 2 minus 4. That is correct. Yes. Yes, Critical. Okay. Yeah, that's how you do it. Okay. So, yeah, unfortunately, yeah, this one is a geometry argument. Where you can pick either just the red one or the blue one. So you can do the red one, get this area, multiply by 4. Or you take the blue one, get the area, multiply by 4. Can you show the entire work? Oh, yeah, it's right here. I mean, this is what I did. I forgot to distribute the 1/2 in. And then here, I'll give you this screenshot so you can see it as well. This is how they did it doing the, they did the other one. Instead of 4, you could just write the sum of 4 integrals. You could, but, so this is, they ended up doing the 1 minus cosine theta, going from 0 to pi over 2. Yeah, so cancel out this. You don't need any of this. We don't need any of this. Don't need any of this. Don't need any of this. This is wrong. This is all you're doing. How do you find the bounds? You kind of just look at it. Right? I see if I'm going, right, from here to here. That's going from the angle pi over 2 to the angle pi. If I was doing the red one, right, it's from the angle 0 all the way up to the angle pi over 2. You see that? And that's what they did. They went from 0 to pi over 2. Oh, okay. Shit. I gotta run. Okay. Sorry, I gotta go teach another student. Bella, I'll take a look at your stuff later tonight. If you're gonna be up late, I'll help you out with 9 to 10. I'll send you a screenshot before you wake up tomorrow morning. Is that okay? Okay, cool. And then here, let me download and send this to you, Critical. If you want to see how to do it. There you go. Cosmic, yeah, I know Cosmic. I'm sorry, dude. Unfortunately, yeah, I have to cut the stream short at an hour and a half today because I have a lot of students with tests tomorrow that are paying me to help them, and I got to pay my rent. It's unfortunate. I wish I didn't have to pay my rent. I know. I wish I could just hang out with you guys all day. Wouldn't that be fun? Lost in Saga. Okay, yeah, there's a screenshot for that. Yeah, you're very welcome. For 19, by the way, just one sec to help him out. What you're going to do is you need to figure out... So this is the area of 2 circles, right, Critical? But you don't want to double count this area, is what you don't want to do, okay? So you're going to do... Yeah. Okay, you want to find out where these 2 intersect, okay? Which here, let me just show you real quick how this is going to work. Okay. So they said, so this is going to be 2 pi r squared, right? Because that's the area of these 2 things. And then you have to do minus the overlap. And now the overlap is going to be this area times 2. So you're going to go from pi over 4, because that's where sine theta equals cosine of theta. That's where these 2 r's equal each other. And so you're going to take the integral, so minus the overlap. The overlap is equal to 2 times the integral, and then this is going to be, yeah, okay, 0 to cosine theta, because that's the blue one. And we're just going to get this area right here. And then that's going to go from pi over 4 to pi over 2. And then that's r dr d theta. So you can figure that out. The multiply by 2 is so that you get like double the half or whatever. Yes, cool. Yeah, 2 times the area of a circle minus the area of intersection. Dr. L's right. I'll save this for you as well. Oh, you remember this stuff? Yeah. Yeah, hope they go well. Okay, cool. All right. Thanks, everyone, for coming to office hours today. Appreciate you guys asking all your questions. The streams next week will be a lot longer. I hope. Anyways, again, thanks for coming by. Our next stream is Monday. That's going to be 3 p.m. Pacific, 5 p.m. Central, 6 p.m. Eastern. If you want to get help, join our Discord. You know the links. Also, yeah, if I'm not here and you still want help, again, we have a lot of awesome math streamers that we work with that also do similar help and things. You can find them. Yeah, Jeff with the mountain time. Yeah. Calendar.actual.education. Just go there for that link, and that will tell you when everyone else is streaming. Who is streaming today? Let me see. I don't think anyone really is. Science. Ask a geologist. Oh, yeah. Go say hi to Rocket. She's a cool girl. Or is she doing anything? Oh, she says, oh, she's be right back. Oh, she's not doing anything right now. Damn. Who am I following? Okay. Looks like Science is doing something at least. Yeah, go say hi to Science. Okay, cool. All right. Have a wonderful rest of your week. Wonderful rest of the Wednesday and Halloween. Awesome weekend. We will see you guys on Monday. Peace.